So KNX IoT, maybe some of you have already heard about this. We've been talking about this extension to KNX since quite a while, but I can now confirm that it is finally there, and I will also invite you to come to our booth. You can already see it live in action. Okay, the content of my presentation, the first question that I will try to answer is, if we look at KNX, maybe we could think, okay, is this not feature complete? Of course, this is a rhetoric question, because, of course, it is not feature complete. And if it's not feature complete, what deficits it may have if we don't do KNX IoT? And how did we solve these deficits? I will round off with a summary, and I will invite you to our booth, which is located in Hall 12, 0B91. Okay, let's get going. The first thing, I draw on the slide is the KNX system. The first robust wired communication everybody has known since ages from KNX is the KNX twisted pair communication. We have added in the 90s the possibilities to also communicate without a wire, so wireless. Even this solution allows battery devices with reduced power consumption, and it even would allow energy harvesting solutions. You heard about a solution just in the presentation before, but KNX would also be able to do that with KNX radio frequency. Then the next thing is in the noughties, as it is called, we extended KNX also towards IP, but this is an IPv4 solution. And we also introduced for all levels, we introduced the possibility to secure the communication on the twisted pair, on the radio frequency, and also on IP, better known as KNX IP Secure and Data Secure. I will explain that in my next presentation. Of course, everything can be configured by the ETS 6 in its 6th generation, and we have a proven interoperability between products of different manufacturers because we oblige the manufacturers to certify their products at an external test lab. Of course, KNX seems to have a nice offer, but it is not complete, and I will name a couple of deficits of the current, I would refer to it as the current or the KNX Classic system. If you want to connect a KNX installation to a third-party product or to systems, KNX still has deficits. If you've got your house equipped with KNX, okay, lovely, all products communicate via KNX, but you buy yourself in the retail, in a retail shop, you buy yourself a Sonos. Okay, very well, you will need a gateway to be able to talk to KNX because this Sonos thing talks another language. Okay, you've got a Huey lamp. You will need yet another gateway because also this Huey lamp does not talk KNX, it talks another language. When you've got this particular brand of boiler controller, then you will also need a gateway because also this brand talks not KNX but a different protocol. So this is not the way you want to fill up your distribution board. So the better solution would be that you have this approach. You also have your home. You also have some native KNX devices inside the installation. You also buy a Huey lamp. You still have your Sonos and you still have your Wyland. But instead of integrating a gateway, these things also talk to a Huey cloud, a Sonos cloud, or a Wyland cloud. The best thing would be, of course, they continue to speak their language, no problem. But wouldn't it be nice if there would be a KNX cloud or a cloud of a KNX manufacturer, and we would offer one single device that would offer all the data towards this KNX cloud in a standardized way. And then all these solutions could, in a standardized way, fetch the data of a KNX installation. Wouldn't that be nicer? Your distribution board would have one single device. Okay, a second deficit is the fact that if you design as a manufacturer a radio frequency product, then you must look at what region you will be selling this product. Because if you're in Europe, you can make, of course, a twisted pair product, a wired communication. But if you want to do wireless communication, Europe requires that you do that in the 868 megahertz range if you want to do communication for short-range devices. If you're in India, you need to do that in 865 megahertz. And if you're in the States, you need to do that with frequency 915 megahertz. You can easily understand that a manufacturer who goes on the market and wants to sell the product worldwide, that he has a problem with KNX radio frequency. So how did we solve that? We have made an extension to KNX that allows you as a manufacturer to continue to make twisted pair products, of course. You can still, if you are only in the European region, you can still make a KNX radio frequency, but you will now also be able to use IPv6 networks, and an IPv6 networks that communicate in a wireless way is, for instance, the thread protocol. The thread protocol allows you to make an IPv6 network which communicates wirelessly, and you communicate fully in an IPv6 frame. So, as a KNX manufacturer doing worldwide business, you simply integrate this thread and you integrate the new extension to the KNX protocol, the Point API, and you can sell worldwide. Another deficit, I've already explained to you that if you want to deliver the data of a KNX installation to a third-party product, that this is difficult. But if you want to make a visualization software, then also the KNX Net IP solution has limitations. The KNX Net IP solution on IPv4, it simply adds the data that is transported also over twisted pair, it adds it in an IP frame. And the KNX is organized in such a way that in a telegram you cannot see what function you are addressing, and you do not know who is the receiver of this data unless you have a copy of the ETS project. The ETS project, so the configuration tool, stores this data in a file, but without a file, you're simply lost. You don't know what this data is all about. You don't know that this is switching a light. You don't know whether this is a temperature. You simply don't know. So we needed a way of handing the data to an IT guy. Mostly these guys are IT guys that develop such a visualization software. We needed to offer this in a modern way, not via KNX Net IP, which is a UDP frame, but with HTTPS, so in a secure way with RESTful web services. And we also needed to add meaning to the data. So the recipient of the data must understand, this is a light in the kitchen. This is a temperature. It's an outside temperature. So we add data, we add so-called semantics to the data, and this interface is completely manufacturer independent because there are a lot of web service driven web servers on the market, but they are manufacturer specific. So each time you need to adapt your visualization to the solution of the manufacturer. This is a manufacturer independent solution. Another fourth deficit of the current KNX is that during the conceptual phase of a building, you have to rely too much on the competences of the involved parties. I will demonstrate that if you want to make your building, of course not with Lego, but a real building. Then the first involved party is an architect, right? The architect typically says, I'm designing a building. I can't be bothered with the technical details. So the inside of a building is not really my concern. I rely for that on a chap called a building designer. In German, ein Planer. And this guy will typically say, I'm very familiar with system X, but the installer might say, I'm a big fan of KNX. And then this building designer will again say, yeah, sorry, I want to stick with this system X because that's what I know. Okay, by adding data to also our product data, so every product in KNX is described in the ETS, but there is meaning missing to make sense of all this data in other tools that will make this conceptual phase much more fluent. If you want to make your building, okay, the architect remains the guy designing the building, fine, no problem. But wouldn't it be nice if the building designer is confronted with a tool where the building designer simply selects the functions he wants to realize, constant light control, for instance, in room X, and this tool will select him the products that would fulfill this exercise. And this tool could also already provide him with a rudimentary ETS project, which he could hand over to the installer. So the installer would only have to fine-tune the ETS installation. He would not have to start from a clean sheet. Also for this, we need these IoT semantics. Okay, summary. We've got still the possibility to design twisted pair products as a manufacturer, radio frequency products, IPv4 products, no problem. We can secure everything, fine. But we add a additional development possibility. We add the possibility to communicate on IPv6, also KNX. On a thread network, for instance, we also add the possibility to offer the data of the entire installation via a manufacturer-independent interface. You could also realize an IPv6 based on single-pair Ethernet or on Wi-Fi, or anything that talks IPv6 can be used. And to connect the existing world with the new world, you will need a translator, because in the old world we had IPv4, in the new world we have IPv6. In the old world we use KNX protocols. In the new world we also use IT protocols, co-ops we use in the new world. So you will need a translator from the old message to the new message and vice versa. But the nice thing is the manufacturers could design a device that holds the possibility to connect to IPv4, to IPv6, even to a cloud system. All of it could be realized in one single device. So we have actually extended the development possibilities for KNX. And all of it will be supported also in ETS. So this new device will be configurable by ETS. Plan is December 2023. You have an ETS 6 on the market, which allows you to also integrate this product in your installation. Okay, again, a summary of what I had said. So we can now also address with KNX device types that we did not cover with KNX yet. We have IPv4, but we also have IPv6. We have own protocol definitions. We inherit protocol definitions from the IT world. We have own security mechanisms, and we have IT security mechanisms. We have, instead of manufacturer-specific web service solutions, we have one common API. We have KNX-specific media, but we also have IPv6 media. We have semantics. We have a quicker time to market for the manufacturers, also for visualization solutions, and all of it is configurable by ETS. So this is my invitation to all of you to give us or to pay us a visit in hall 12.0 B91. I can also, if there are any manufacturers listening to my presentation, we have a novelty as KNX. For the first time, we are also providing an open source stack for the IPv6 solution. So this is completely open. Anybody can look into this, and I think this is very interesting for people who until now did not develop any KNX products. Thank you very much. These are my contact details. If you have any questions, of course you can raise them now, or you can raise them via email. Thank you very much.